For this first problem, we're supposed to determine the range of values for the force P, which for the block not to slide. It's interesting that this problem says what is the range of values, right? We would just think that there'd be a value for P such that the block will not slide. But if we look at this more closely, this block has the ability to slide up, right, if I'm pulling too much force, or if I'm not strong enough, this block has the ability to slide down. So we have a range of values for P such that this block will either slide up or down. So let's look at one of these cases. The first case we want to look at is the sliding up case. It doesn't matter which one you look at first, but this is the one that I'm going to look at. The next step that we do when we do this is to draw our free body diagram. If we look at it, we have the weight of the block coming down. We have a normal force, right? Normal is always perpendicular to the surface itself. And then we have our friction force. Notice that this friction force is drawn such that it is impeding the motion, right? It's resisting the motion. The motion is to go up the surface. We want to impede that or resist that motion, so our frictional force will go down. And then last we have our force P on here for it. We have drawn a coordinate system of N and T. I'll redraw those, though, for us as a more familiar for us, for some of us, as X and Y. The next step is just like any other problem that we do these, we look at our equations of equilibrium. We have on here our angles or our 3, 4, 5 triangles. We can now write our equations of equilibrium. I'm going to first write my equation for the y direction. And that equals a minus 100 pounds times 3/5 plus n. Now we can solve for our normal force. N ends up being 60 pounds. Next, we will do the x direction. The x is minus 100. This is our weight. 4/5 minus mu n plus p. We don't know what p is. And we do know our coefficient of friction. That was given to us as mu equals 0.2 in the problem. We then can take our n value that we just solved, our normal force, and add in our coefficient of static friction, and we can solve for P is equal to 92 pounds. 92 pounds is the force in which if I add more force than 92, anything greater than 92, this thing will start sliding up. Next, let's look at the other case where this thing is trying to slide down. We draw our free body diagram again. Remember, our motion that we're looking at is this thing wants to go down, is our motion. That's our motion. So to impede that motion, I have my friction. Okay. Again, we will look at our x and y for this. This will be our x. This is our y. And again, our coefficient of friction is 0.2. So first we'll solve for our forces in the y direction. And we see that that is the same as it was for this object sliding up. And then last we will look at our forces in the x direction. And that is a minus 100 pounds. This is still our weight of 4/5 plus this time mu n plus p And if we solve for this, P equals 68 pounds. So how does that compare with the other, and what is our range? Our range for P on here is P is less than or equal to our 68 pounds. Anything less than 68 pounds, this thing will start sliding down, and our upper range is 92 pounds. Now realize that these are design parameters. Our coefficients of friction aren't always exactly 0.2, but it gives us a point to start designing right from. Otherwise, we don't know where to design from. So this is just a starting point for our designs.